kids, how are you? I hope you're all fine. My name is Nirtoyana, BSc. Currently, I am available at the Hamlet Tuition Center, Brahmatal, Kathmandu, and Kumudini Kunja Secondary School, Kalimati, Kathmandu. Today, we are going to continue our discussion. We are going to continue our discussion on the lesson Work, Energy and Power, grade 9, Work, Energy and Power. Okay, we have been discussing about this lesson since for I guess 3 days, isn't it? In our first day we discussed about work. Yes, work, types of work and components of work, and then calculation or measurement of work. And in our second class we discussed about types of energy and types of energy on the basis of simple mechanic, that means kinetic energy and potential energy. On our third class we discussed other types or forms of energy. Today we are going to discuss about conservation and transformation of energy. Okay, now let's start from conservation. What do you mean by conservation? Well, conservation means to conserve or not let to destroy. Yes, if you do not let something to get destroyed, then that is called conservation. Yes, so basically conservation of energy means energy cannot be destroyed. Its basic meaning is that energy cannot be destroyed, isn't it? Now think of it. let's take an example of a battery. Yes, a battery. You all have seen a battery, isn't it? Yes. Okay. In a battery, one of the part is known as plus terminal, and another part is known as minus terminal. Yes. We use battery in several applications. In several fields, we use battery, isn't it? For example, in torchlight. Okay, in torchlight, and in remote control, in our watch. Yes, in several devices, in cars, isn't it? Actually, remote control car, toy car, yes, not real car, and car, and in many other devices we use battery. Yes, if we are talking about conservation of energy, if we are saying that energy can never be destroyed, isn't it? It says that conservation says that energy cannot be destroyed. It is never destroyed. Then how come it that battery gets out of charge? Once you use a battery, once you get a battery, can you use it for lifetime? एउटा ब्याट्री किनेर तिमीले रिमोट कन्ट्रोल कारमा राख्यौ भने के त्यसलाई तिमीले लाइफ टाइम भरि सधैँभरिकोलाई चलाउन सकिन्छ? Can it be? No. Energy cannot be destroyed. So the question is here, why, if energy is not being destroyed, then what is happening here? Why does this battery finishes, or why does this battery dies? Okay, the reason is energy definitely cannot be destroyed, but the energy is being transformed. Okay, the energy is being transformed. Like if you have connected this this battery to an electric bulb. Okay, if you have connected this battery to an electric bulb, then what is happening actually here? Okay, what is happening is the chemical energy present in the battery. Yes, the battery contains which type of energy? It contains chemical energy. That chemical energy is first being converted into electrical energy, and then it is being converted into kinetic energy. Okay, so not kinetic energy, I'm sorry, it is being converted into light energy. Are you getting me? Yes. Okay, since the energy content in the battery is being converted to light energy, yes, we keep on getting light energy, and the chemical energy of battery keeps on finishing. Okay, so what's happening here is actually energy is being transformed into another form, but energy is not being destroyed. Okay, energy cannot be destroyed. And same oppositely, if energy cannot be destroyed, then it cannot be created as well. Okay, energy cannot be created as well, not just destruction, but it cannot be created. Okay, so energy is neither being created nor being destroyed, but the only possibility is transformation of energy. Okay, transformation of energy is the only possibility. Okay, now here also, by without connecting battery, if you simply remove the battery, if you simply remove the battery, then will the bulb glow? Will it glow? We all know that if we remove the battery, the bulb will not glow. It will not glow. The bulb goes off. Okay, then where is light energy? You can see that light energy cannot be created. Light energy cannot be created. Okay, unless you add add a battery. In this case, what is happening? Light energy is not being created, but the chemical energy present in battery is being converted to electrical energy, and then that electrical energy is being converted to light energy. Okay, that is the essence of today's lesson. Okay, this is very easy topic, it's not very difficult. Okay, look here, principle of conservation of energy says that energy can neither be created. I hope this part will not be so much confusing, is it? Energy can neither be created nor be destroyed. Okay, neither be created nor be destroyed. Create पनि गर्न सकिन्न, destroy पनि गर्न सकिन्न, but only option is that, but can be transformed from one form to another form. खाली एउटा फर्मबाट अर्को फर्ममा ट्रान्सफर्म मात्रै हुन्छ है। यसको एक्जाम्पल हामीले पक्कै यहाँ डिस्कस गरेका थियौँ। हेर त, यो केसमा के भइराखेको छ, ब्याट्री, यो ब्याट्रीमा कुन चाहिँ एनर्जी छ अरे? ओके, ब्याट्री कन्टेन्स chemical energy, yes. Okay, battery contains chemical energy. Okay, actually यसो गरौँ, let's take it down, make it like this. Okay, it looks better. Yes, battery contains chemical energy. Yes, and when it goes to circuit, it gets transformed into which energy? Electrical energy. Okay, the chemical energy is transformed into electrical energy, and when that electrical energy passes through the bulb, then the same electrical energy is being transformed into now light energy. Okay, are you getting the concept or not? Look, it is very easy. Yes, chemical energy is being converted into electrical energy, and that electrical energy is converted into light energy. But none of the energy neither being created nor being destroyed. But where does this light energy go? My question. Light energy, where does this light energy go? Actually, the light energy dissipates in the form of moving photon. Yes, that photon, the photon particles that are released from the bulb, they can actually travel to infinite distance. They keep on traveling, and at some point they also dissipate in universe in the form of heat energy. Okay, the universe acts as a big sink, a huge sink that absorbs heat energy produced in every types of reactions, every types of process, okay, in the whole universe. Okay, the space acts as the sink for energy. Okay, that's why we keep on losing energy to the space. Yes, Okay, now in conservation of energy, we discussed, we claimed that energy cannot be created, energy cannot be destroyed, but in our surrounding, what's happening? Energy being transformed from one form to another form, and this process in which the one form of energy transforms into another form is called transformation of energy. Okay, transformation of energy. And while energy is transformed, certain work is performed. Okay, the transformation of energy always performs certain work. That is why work is also defined as the amount of energy being transformed from one form to another form. Okay, remember it. The work is also defined as the amount of energy being transformed from one form to another form. Okay, so certain work is performed when energy transformation occurs. In fact, all the processes in nature occurs through transformation of energy. Okay, whatever process you take, okay, um, be it the growing of tree or burning of fire, okay, or revolving around the sun, moon revolving around the earth, the tide rising in ocean, okay, whatever process you can see in your surrounding, they all are happening through transformation of energy. Everything is happening through transformation of energy. Now we are going to discuss some examples here. Okay, some examples. Okay, the first example is uh, hydroelectric power plant. Okay, hydroelectric power plant. How many of you have visited some visited what I forgot the name. Okay, Chilime hydro power plant. Okay, or the nearest one, what is that? Indra Sarovar. Yes, Kulekhani. Okay, Kulekhani hydropower plant. Okay, or if you want to visit a small scale hydropower plant, then you can go to Thorping. Okay, that actually name of place is Thorping. Chandra Tri, okay, Tribhuvan Chandra hydro power Thorping. Okay, uh, some of these hydropower plants, okay, among them Tribhuvan Chandra hydropower or Thorping hydropower is the nearest to us. You can easily visit there. Yes, and then after Kulekhani hydropower is also it there. You can get there in the same day. It takes around 3 hours in bus, okay, to get there. Yes, so you can visit there as well. But the problem is in Kulekhani, this is a large scale hydropower station. Okay, and there is it is very dangerous to get inside. Okay, that's why visitors are generally not allowed inside the hydropower plant when it is being operated for safety reason. Okay, it's very dangerous to get inside. And you know the children, or especially school kids, okay, teenagers, they they are usually what to say, like chaksake. They don't like to be bound by rules. Yes, so they usually don't follow the safety rules. Most of them definitely do follow, but we need to count even one not following the rule, because life of every individual is precious, isn't it? Yes, that is why these large hydropowers usually do not allow the visitors in, but you can visit Thorping hydropower. It is small scale hydropower station. Okay, and they nowadays they do not generate electricity. Okay, because of problem of water. You know, Kathmandu Valley, yes, there is very sharp shortage of water. It's very critical. It's critical shortage of water resources in Kathmandu Valley. That's why Thorping hydropower station is not being operated nowadays, but you can visit there. A government official has been appointed in that station to give you some briefings, okay, to tell you everything about the hydropower station. It was very nice visit when I took my students there last year. Okay, let's see how does a hydropower plant operates. A hydropower plant has a reservoir, yes, a dam. Okay, this is the reservoir. Okay, this is dam. Yes, this is dam. Dam is actually an artificial wall, isn't it? Dam is an artificial wall. Yes, that dam blocks any flow of water and makes the causes the water to stay or to be stored within the walled structure, and that stored water is known as reservoir. Okay, reservoir is usually very deep. If you fall into one, then don't expect to get up. Okay, even if you are very good swimmer. That's why you should be very careful when you visit such reservoirs or dam. Okay, and here at the bottom of dam they keep a channel, okay, underground channel pipeline, which is also called penstock. Okay, and the opening of such pipeline or channel is known as intake. The intake is guarded by very strong door like structure. Okay, very strong door like structure, okay, which blocks the water flow through the penstock. And at the end of penstock a turbine is kept. Okay, that turbine is connected to a shaft. Yes, here is the shaft. Okay, and through that shaft is connected to the coils of generator. The generator contains coils, and those coils are placed within very strong magnetic field. Okay, two magnets, very strong magnets with north and south pole, are kept, okay, around the coil, but the coils do not touch the magnet. And you know, according to Faraday's law of electromagnetic induction, when magnetic field linked to a conductor is changed, then electricity is induced. You will study about this law or this property, this mechanism in detail in grade 10. Okay, now what happens is when this intake gate is opened, okay, when this valve is opened, water from reservoir they start to flow through penstock, and due to the height of water, this water flowing through penstock has very high pressure and very high speed, and that high speed and high pressure water flow rotates turbine at very high speed. Okay, that causes turbine to rotate at very high speed, and that water then flows through this pipe to outlet. Okay, and then this rotating turbine rotates the shaft. Okay, the rotating shaft rotates the coil in generator. When the coil is rotated within magnetic field, it produces electricity, and that electricity is fed into electrical grid. Okay, and that electricity is supplied to our home. Now let's study about um, change in energy. Okay, transformation of energy. What's happening here? Let's see. Okay, let me take a different color. Okay, red. Okay, here when water is in reservoir, it has actually potential energy. Okay, the water in reservoir has potential energy. Yes, when that water starts to flow through the penstock, then the same potential energy gets converted into kinetic energy. Yes, when water flows through penstock, the potential energy is converted into kinetic energy. When the water force of water rotates the turbine, okay, the kinetic energy is transformed. Yes, kinetic energy is transformed from water to turbine, and when that turbine rotates a coil of generator, then the kinetic energy is converted into electrical energy. Okay, we are seeing here the transformation of energy, potential energy being converted to kinetic energy, and then that kinetic energy is transferred to the turbine, and the kinetic energy is then converted to electrical energy by powerhouse. Okay, okay. we need to describe the transformation of energy in detail. Yes, in word. Okay, let's describe it. The transformation of energy takes place in following way in a hydroelectric power plant. First, first of all, what happens here? Water stored in reservoir. Okay, I'd like to make a box, but I guess okay, this is okay. Water stored in reservoir contains potential energy. Any doubt or any confusion? Number B, when water flows in penstock, PE transforms into kinetic energy. Number C, when flowing water rotates the turbine, KE is transferred from water to turbine. Yes. Number D. Okay. Number D. When turbine operates generator, KE is transformed into electrical energy. Okay, this is it. First of all, potential energy, then what's happening, then kinetic energy. Okay, and then that kinetic energy is transferred to turbine, then that kinetic energy is transformed into electrical, converted into electrical energy. Okay, this much is about hydroelectric power plant. Is there any confusion? If still you have some confusion, I have found a video, okay, an animation in YouTube. You can watch this video. Although this video is of 6 minutes, but working mechanism is given in 2 minutes.
The height of the water from ground level, volume of the water flowing per unit time, and efficiency of the turbine. Hydroelectric power plant requires a water reservoir. So these plants are constructed near big dams. Water stored in dams has potential energy. The water under pressure is carried by penstock and supplied to the turbine through the inlet valve. Penstock is a pipe made up of steel or concrete. A surge tank reduces the excessive water force on the penstock. Here, trash rack prevents the debris from getting entry into the powerhouse. Due to the force of water, the turbine starts rotating, due to which mechanical energy is produced. The shaft from the turbine is connected to the generator. Therefore, the generator produces the electricity. The voltage of this electricity is raised by using a transformer and is transferred by the distribution lines. After running the turbine, the water is passed to the downstream water level by draft tube. The demand of electricity varies by day and night as well as among the seasons. Hence, there is a need to store the energy so that it can be used at the time of high electricity demand. This can be done by using pump storage process.
Okay, that's all the mechanism of hydropower station. Other parts of this video are not within our scope. Okay. Okay. Next example, let's go to nuclear power plant. Okay, next example we are going to discuss is thermonuclear power plant. Okay, okay, thermonuclear power plant. Okay, last time also we discussed about this. Do you remember or not? In yesterday's class we discussed about thermonuclear power plant, isn't it? I'm going to tell you in brief once again. Here what happened, we have a reactor vessel. Yes, reactor vessel have, what does it have? Well, it has radioactive elements. These radioactive elements undergo nuclear fission reaction and produces heat energy. That heat energy is transferred to water in this vessel. Okay, and that water revolves through this channel. Okay, circulates through this channel, and that water will heat up the water in steam generator here in this. Okay, in this chamber, this is steam generator. It contains water. That water is heated up by the hot water flowing in this tube. Okay, okay. So because of that heat energy, water in this generator, it evaporates. Okay, that produces lot of steam, and that steam is transferred through this pipe into turbine at very high pressure. Due to the pressure of water, the turbine rotates, isn't it? And that water is transferred through the condenser. The condenser then condenses the water vapor back into water, and that water is pumped again into steam generator to recycle the water, or to recycle the process. Okay, come here. The turbine rotates. The turbine is connected to a shaft. Okay, just like in hydroelectric power plant, the shaft is connected to coils in the generator, isn't it? And the coil is placed between magnet, between in the magnetic field. Okay, so when the coil placed within magnetic field rotates, it produces electricity. Okay, that electricity is supplied to city. Now let's discuss about energy transformation. First of all, which energy is present here? Definitely it's nuclear energy, isn't it? Nuclear energy is present in the radioactive materials, radioactive elements kept in the reactor. Okay, okay, let's make it of different color, shall we? Yes, nuclear energy. Then that nuclear energy is converted into heat energy. Heat energy. Yes, when because of nuclear energy, because of nuclear reaction, it produces heat energy, and that heat energy evaporates water vapor, isn't it? And when that steam moves through the pipe channel at very high speed, which energy is created here? It has kinetic energy. Okay, and that kinetic energy is transformed into turbine, and finally the kinetic energy is converted into electrical energy by the generator. Okay, this is the transformation of energy in thermonuclear power plant. First of all, nuclear energy to heat energy, isn't it? Okay, nuclear energy to heat energy, 4 points, and then after heat energy to kinetic energy. Okay, and then after, okay, 4 points, curve, kinetic energy. That kinetic energy is transformed. Yes, okay, and then after the kinetic energy is converted to electrical energy finally, and that electrical energy is then supplied to city. Okay, or transmission line. Okay, then it is supplied to city and household. Okay, this is the transformation of energy that takes place in a thermonuclear power plant. Okay, let's erase this. We are going to explain it. Okay, here. Okay, in the energy transformation, you can start writing, occurs in following way in a thermonuclear power plant. First of all, radioactive elements such as uranium, okay, has nuclear energy. Number B, during nuclear fission reaction, nuclear energy is transformed into heat energy. Number C, the heat energy evaporates water from steam. As the steam moves through channel at high pressure, it generates kinetic energy. Need to make some tabbing here. Okay, that's it. Kinetic energy. And then what's happening here? The steam, okay, as when the steam rotates the turbine, kinetic energy is transferred from steam to turbine. Number E, as the turbine operates generator, okay, kinetic energy is transformed into what? Electrical energy. Okay, this is the transformation of energy. Okay, you have to explain this much. Okay, first nuclear energy, then heat energy, then what? Then kinetic energy. That kinetic energy is transferred, and finally the kinetic energy is converted into electrical energy. Okay, this is how a transformation of energy takes place in thermonuclear power plant. Okay, pause the screen, copy it if you need. Okay, now let's take a look at other examples of transformation of energy. In case of torchlight, what's happening? The battery contains chemical energy which is transformed into light energy by torchlight. Yes, in this example, the petroleum contains chemical energy, and that chemical energy is transformed into mechanical energy by car. Okay, and food contains chemical energy which is transformed into mechanical energy by our muscles. Okay, similarly, the light bulb converts or transforms electrical energy into light energy. Okay, let's take a look at other examples. Okay, here an oven is shown. Yes, the oven. Okay, once again, the oven converts electrical energy into heat energy, and green plants convert light energy into chemical energy. Okay, this much is about transformation of energy. Now our last topic for today is power. Power is defined as the rate of doing work. Very easy. Okay, power does not mean that how strong you are, isn't it? When I ask you whether elephant or horse, among elephant or horse, which one is more powerful? If I ask you, many students or many people would answer that of course elephant is more powerful, isn't it? Even you would answer that, yes, elephant is more powerful. But note this, power does not mean how much work you can do. Okay, power does not mean how much work you can do, it means how fast you can do the work. Okay, rate, look here, the word rate. Okay, rate means how much work you can do per second time. Yes, that is amount of work done per unit time. Okay, per unit or per second time. If you can do more work in 1 second time, then you are powerful. Okay, let us suppose that. Okay, um, let's get to two examples. Yes, in one example I will consider elephant, and in another example I'll consider a horse. Okay, let's say in total elephant can perform 5,000 joule of work, whereas horse horse can perform only 3,000 joule of work. Okay, let's say that's okay, just say 2,000 joule of work, isn't it? Let's say elephant can do more work than horse, isn't it? Elephant is strong, but to do that 5,000 joule of work, elephant takes around 50-second time. Okay, elephant takes 50-second time, isn't it? However, horse horse can do this 2,000 joule of work within 10-second time. Within 10-second time, horse is very fast. Yes, everyone knows that. Elephant is very slow, but horse is very fast. Now, uh, if you need to calculate power of both of them, you know, if elephant is doing 5,000 joule of work in 50-second time, in 1 second time, how much work is he doing? In 1 second time, how much work is he doing? Definitely he is sorry. Okay, definitely he is doing 100 joule per second. Okay, the elephant is doing 100 joule of work in 1 second. However, the horse is doing 200 joule of work per second. See the difference? See the difference? Definitely elephant has the capacity to do more work. That means elephant has more energy. Okay, don't be confused. More energy. Elephant has more energy, but the horse has more power. Okay, horse has less energy. See, the capacity to do of work means energy, isn't it? You have studied it. What is okay? What is the capacity to do work? You know, it is energy. Energy is defined as capacity to do work. So elephant has more capacity to do work, means elephant is more energetic. Okay, elephant is more energetic, or you can say strong. Yes, but horse has less capacity to do work. However, it can do work faster than elephant, so you can say horse is more powerful. See, there is a basic difference in saying powerful or strong. Yes, powerful does not mean strong. Okay, and strong does not mean powerful. They are different sense. See, this is the note. The one who can do more work are strong. They're not powerful. But the one who can do work very fast are powerful. They may or may not be strong. Okay, now come to point. SI unit of power is watt. Okay, and mathematically power is defined as work divided by time. Okay, so look at this relation, power equals to work divided by time. That's why it is called rate of doing work, or work done per unit time. Okay, and taking all units, so taking units of all terms, what do you get? Okay, we know the formula of power is power equals to work upon time. Now take the unit of power. We know it is watt, isn't it? 1 watt. And take unit of work. What is the unit of work? It is 1 joule. Yes. And take unit of time. What is unit of time? It's 1 second. Okay. Now from here you can define 1 watt power. Okay. Therefore 1 watt power is defined as capacity of doing 1 joule of work in 1 second time. Okay, this is important point. Okay, because you are frequently asked to define 1 watt power, then you need to do this much. Yes. Now come to numerical, and it's quite easy. Okay, I guess this is the last portion of our lesson today. Okay, and its answer, and I hope you can very easily do it. Yes. Okay, first of all you need to take given information. Weight of the ball, or force or weight. Yes, you know that force and weight are same thing. By now you should know that force and weight are same thing. That's why I'm giving the symbol F for weight of the ball. Ball weighing 350 Newton means force is 350 Newton. And it climbs up a hill raising her vertically 5 meter means what is her displacement? Displacement, or S, is equals to 5 meter. Yes. And how long time does it take for the displacement? It is 20 seconds. This much is given. You need to find power. P equals to what? As we know, P is equals to W by T, isn't it? P equals to W by T. Yes. Now, are we given the value of W? No, we are not given work done. Yes, but we can use the formula of work done. Work done means F multiplied by S. Yes, divided by T. Force into displacement is work done. Now we have all the values given. We need to find P equals F 350 Newton multiplied by S displacement 5 meter divided by time 20 seconds. Okay. Therefore, what does it give? Okay. Therefore, P is equals to, just multiply it. 35 times 2, 70. 70 times 5, 7 5s are 35, 350, and you still have double zeros there. What? Okay, this is your answer. Any confusion? Any confusion up to here? Okay, if no confusion, wait, am I doing any mistake? Especially in calculation. 350, yes, 350 times 5. Okay, let me calculate it again. Okay, 350 into 5 divided by 20, 87.5. Means, okay, I made a mistake here. 87.5 watt. Okay, this is your actual answer, 87.5 watt. Actually, I here I needed to divide, yes, but I multiplied. That was my mistake. Okay, anyway, sorry for that. Give the conclusion. While doing numerical, don't forget to give conclusion. Okay, therefore the power of the girl is 87.5 watt. Okay, this much. Okay, this much for today. Our lesson is completed. I'm going to send the photos of exercise in your group. Please go through please come to the group, messenger group, for your homework for today. And I'm giving you 2 days time, okay, not TODAY today. I'm giving you TWO 2 days time. And I guess some of you might need extra time, okay, in case you cannot complete the work in 2 days. In that case, I'm giving you 3 days time, and we will resume our class in 3 days time. That means Sunday, okay, and the third means Sunday we will resume our class, and we will start another lesson, okay, chapter 5, sound. Okay, until then, goodbye students.